In this video, we are going to talk about the unit circle. So let us first understand the basics of the unit circle. So unit circle, as the name suggests, the unit circle is the circle that has the radius of 1 unit. Okay, so the radius of the unit circle is 1 unit, and the center of the unit circle is at the origin. Okay, which means at the point 0, 0. So this is the definition of the unit circle. So let's see how does it look like. So this is the unit circle whose center will be at the point 0, 0. So here is the center of the unit circle at the origin. And since the radius is 1 unit, so therefore this point's coordinates will be 1, 0. This is the positive x-axis, right? This is the x-axis and that's the y-axis. And therefore, the coordinates of this point will be 0, 1. The coordinates of this point will be negative 1, 0. And the coordinates of this point will be 0, negative 1, right? Since the radius is 1 unit. So this is the definition of the unit circle, and that's how it looks like. It's very simple. Now there are a few things that we need to understand. Okay, let's take any point over here on the unit circle, right? Any point on the unit circle, let's say this point is P. The coordinates of any point on this unit circle can be represented by cosine theta, comma sine theta. Now what is theta? Theta is the angle that this point is making with the positive x-axis. Okay, this is very important. So this point is making an angle of theta with the positive x-axis. Now this angle can be in anti-clockwise direction, right, which means in this direction, and this angle can also be in the clockwise direction, which means in this direction, right? So let's say that this point P is making an angle of theta in the anti-clockwise direction as shown by this arrow, and this point P is making an angle of let's say alpha in the clockwise direction. So let's say this angle is alpha. Uh, in both the cases, the coordinates of this point will be represented by the cosine of the angle. Now, the angle can be either anti-clockwise or the clockwise. It does not matter, right? Both will give you the same answer. So therefore, another way of writing the coordinates of this point will be cosine of alpha, comma sine of alpha, right? So as long as you're measuring the angle from the positive x-axis, no matter if it is a clockwise angle or anti-clockwise angle, the coordinates of point P can be written as cosine of the angle, comma sine of the angle. Okay. Now, what is the difference between anti-clockwise angle and the clockwise angle? Anti-clockwise angle is written as the positive angles. Okay, so this angle theta over here is the anti-clockwise angle, and anti-clockwise angles are measured as positive or written as positive, right? Um, and on the other hand, the clockwise angle, which is alpha in this case, so clockwise angle are written as negative, right? So that's the difference between anti-clockwise and clockwise. So for example, let's take a unit circle again, and let's say that there is a point P on the unit circle over here. Okay, and this point P is making a an anti-clockwise angle of 30 degrees. Okay. Now, if you have to write the clockwise angle for this point P, then it would be this angle, right? This would be the clockwise angle. Let's say this is alpha. Now, what will be alpha? Alpha will be equal to, so we know that the full circle makes, like, one rotation makes 360 degrees of angle, right? So if we have 360 degrees as the full rotation, and if we can subtract this much of 30 degrees from 360 degrees, then we can get the remaining angle, which will be alpha, right? So therefore, alpha will be equal to 360 degrees minus 30 degrees, which means it would be equal to 330 degrees, right? But because alpha is the clockwise angle, so we have to write a negative sign in front of it, right? So we have to write the negative sign. So the negative sign just indicates that the angle is measured in the clockwise direction. That's it. Whereas for anti-clockwise angles, the angle will be written as positive. So yeah, that's about the sign conventions. Okay, now that's just the basic of the unit circle. Let me discuss one more thing. Okay, for this part, let me draw a big unit circle. Okay, okay, so this is a unit circle, and this is the x-axis, and this will be the y-axis. Okay, now once again, the center is at 0, 0. Okay, now let's say that there is a point P once again on the unit circle over here. This is point P, and the coordinates of this point P, let's say that this point P is making an angle of theta in anti-clockwise direction, okay, which means this angle is theta in anti-clockwise. So the coordinates of this point P can be written as cosine of theta, comma, sine of theta. Okay, now let me take another point on this unit circle, which is exactly opposite to point P in this region. Okay, so exactly opposite means that another point on this unit circle that I will be taking will be over here. Okay, so let me do it. So the other point will be over here. Let me call this as point Q. Now I have to write the coordinates of this point Q. And in order to write the coordinates, I need to first find the angle that this point Q is making with the positive x-axis. So what I'll do is I'll just draw a line connecting this point Q with the origin. Now, since this point Q is at the same height as point P, right? Because this point P is just opposite to point Q. So these 2 points are the same height. Therefore, since they are the same height, what I can say, and since this is a unit circle, uh, therefore this distance L from the origin to point P, this horizontal distance, will be the same as this horizontal distance from the origin to point Q as well, right? Because this is just a unit circle and symmetrical. So horizontal distance will be the same, and the vertical distance, let me say that the vertical distance is, um, let's say this is x. This vertical distance from the x-axis to point P will be the same as the vertical distance from the x-axis to point Q, right? So therefore, what I can say is that the coordinates, the x coordinate of point Q will be the same as x coordinate of point P, but it will be negative. for point Q, right? Because this is a negative x-axis. So therefore, the coordinates of point Q will be negative cosine theta. This will be the x coordinate. What will be the y coordinate? Since they both are at the same height from the x-axis, therefore the y coordinates of point P and Q will be the same. So therefore the y coordinate of point Q will be sine theta, right? So that's what I can say. Uh, Now let me write the coordinates of point Q by first getting the angle of point Q. Now since both these points are on the unit circle, if this um, if the point P is making an angle of theta with the horizontal, therefore point Q will also make an angle of theta with the horizontal. Okay, so therefore this little angle will also be theta. And in order to find the angle of point Q, I have to always measure the angle from positive x-axis, right? I cannot measure from negative x-axis. So I can either measure in anti-clockwise direction. Okay, so this angle will be the angle of point Q, or I can measure in the clockwise direction. So this angle will also be the angle of point Q. So let me actually calculate the angle in anti-clockwise direction. So in anti-clockwise direction, this big angle will be the angle of point Q. Uh, Now let us calculate what will be this angle. So if this angle is theta, and we know that the angle in a straight line is 180 degrees, right? A straight line makes 180 degrees angle. So therefore, this angle will be 180 degrees minus theta, right? So this angle will be 180 degrees minus theta. Now we know the anti-clockwise angle of point Q. So I can write the coordinates of point Q with respect to this angle. So they will be cosine of 180 degrees minus theta, comma sine of 180 degrees minus theta, right? So that's how I can write. So these are the two ways of writing the coordinates. Both will give you the same answer, right? Okay. Now I can also extend the same logic uh, to other regions, like this region, for example. So what I'll do this time is I will pick up a point on the unit circle again, which is exactly opposite to point Q. So let's say this point. Let me call this as point R. The coordinates of point R I need to calculate. So for the coordinates of point R, what I'll do is first of all, I will connect the point with the origin by drawing a line. And once again, since point Q and point R are on the unit circle and point R is just opposite to Q, so therefore if this angle is theta, so therefore this angle must also be theta, right? So because if point Q is making an angle of theta with the horizontal, so R will also make the same angle with the horizontal, right? So therefore this angle will also be theta. In order to write the coordinates of point R, I need to find either the anti-clockwise angle or the clockwise angle. So let me just find the anti-clockwise angle. So the anti-clockwise angle for point R will be this big angle. Okay. Now, how much will this be? We know that in a straight line, the angle is 180 degrees, and we need to add this little bit of angle, which is theta, to 180 degrees. So this whole angle will be 180 degrees plus theta. Okay. So this angle will be 180 degrees plus theta. So now I know the anti-clockwise angle for point R. So I can write the coordinates of point R, which will be cosine of 180 degrees plus theta, comma sine of 180 degrees plus theta. So these will be the coordinates of point R. right? What is the other way of writing the coordinates of point R? Uh, we know that the coordinates of point Q are negative cosine theta and sine theta. Negative cosine theta is the x coordinate, and since Q and R both have the same x coordinates, right? So therefore the x coordinate of R will also be the same as the x coordinate of point Q, which is negative cosine theta. Okay, so negative cosine theta is the x coordinate. Now what will be y coordinate? The y coordinate of point Q is sine theta. Okay, and we know that Q and R will have the same distance, same vertical distance from the x-axis. However, R is on the negative y-axis. So therefore, the magnitude of the y-coordinate of R will be the same as the magnitude of the y-coordinate of point Q, because both are at the same vertical distance from the x-axis. However, R's y coordinate will be written as negative because this is in the negative y axis. So therefore, the y coordinate of R will be negative sine theta. Okay, negative sine theta. So this is another way of writing the y coordinate, x and y coordinates of point R. These two will give you the same answers, right? Which means that this is equal to this, right? So negative of the negative cosine theta is equals to cosine 180 degrees plus theta, and similarly this is equal to this, right? And by the same logic for Q also, this is equal to, I mean, these two are equal and these two are also equal. Okay, now finally I can also do the same thing in this last zone. Okay, later on we will see that there are names for these zones. This is called the first quadrant, this is the second quadrant, this is third quadrant, and this is fourth quadrant. Okay, so let's do the same thing for this. Now once again uh, I will get a point opposite to point R in this zone, so let me call this as point S. Now this point S will also be exactly opposite to point P, right? Yeah. Okay, now what will be coordinates of point S? Now once again I have to connect point S with the origin, and by symmetry, um, this point S will also make an angle of theta with the horizontal. Okay, now I have to find the angle of point S from the positive x-axis. Now what I can do is I can find either the anti-clockwise angle, this angle of point S, or I can find the clockwise angle, this angle of point S. And I already know that this angle is theta. So therefore the clockwise angle will also be theta. However, it will be written as negative, right? Because the magnitude of theta is positive, right? This was theta originally. The magnitude of theta is positive. So I have to write negative theta for the clockwise direction. Okay, or simply I can just take the anti-clockwise angle and write it as the positive. So it's up to you, whatever you want to choose. Okay, both will give you the same answers. So let me choose anti-clockwise angle first. Okay, so what will be the anti-clockwise angle? Anti-clockwise angle will be this angle for point S. Now how much will this be? We know that full circle makes 360 degrees, and we need to subtract this angle theta from 360 degrees in order to get this much of angle. So this much of angle will be 360 degrees minus theta, right? Because this angle is theta. So therefore this angle is 360 degrees minus theta, and this will be the anti-clockwise angle for point S. So I can write the coordinates of point S, which will be cosine of 360 degrees minus theta, comma sine of 360 degrees minus theta. So these will be the coordinates of point S. If you are taking the clockwise angle, which will be written as negative theta, then the coordinates of point S can also be written as cosine of minus theta, comma sine of minus theta, right? That's how you can write the coordinates. Um, now, there are other ways of writing the coordinates of point S, like uh, for example, you know the coordinates of point R, which will be cosine 180 degrees plus theta and sine 180 degrees plus theta. We know that point S x coordinate will also be the same, however, it will be positive, right? Um, yeah, it will be written as positive. Okay, the magnitude will be the same, but it will be positive. Cosine of 180 degrees plus theta will give you a negative answer. Okay, because this is the negative x-axis, so it will give you the negative answer. So which means that you have to add a negative sign in front in order to write the x coordinate of point S if you're writing in terms of the coordinates of point R, right? Because the x coordinate of S will be positive. And similarly, the y coordinate of R will be the same as the y coordinate of S. So it can simply be written as sine 180 degrees plus theta. So these are the different ways of writing the coordinates, right? So yeah, that's how you can get the coordinates uh, of so many points if you just know the coordinates of one point, right? If you just know the coordinates of point P, you can find the coordinates of point Q, R, and S. Okay. Later on, when we will be solving trigonometric equations, we will see applications of this thing. So, like if you know the angle in one quadrant, then how would you find the angle in some other quadrant of the point opposite to that point, right? Okay, so these were just some basics about the unit circle. In the next few videos, we will be showing you how to apply these basics of the unit circle in order to solve the trigonometric equations. Okay, good luck.